Hello everyone, Marcos Colon, online editor with SC Magazine, and joining me today is Caleb Barlow, who's the Director of Mobile Security at IBM. IBM's been doing some pretty interesting work regarding application security, and you were sharing some insight about some rogue apps out there that are plaguing enterprises and the creators of these apps as well. Can you talk a little bit about that?
Sure. I mean, I think one of the biggest challenges, Marcos, with mobile security today is that, we have to move the security perimeter into the application itself, right? We'd all gotten comfortable in kind of the laptop metaphor with security really being on the edge of the device. But now when we think about mobile, people are bringing these devices into work on their own. They're downloading these applications from stores, and we don't necessarily even know what all these apps do. So we actually have to build security provisions into the application themselves. One of the more amazing things when we think about applications is of the top 100 applications out there, a study from a company called Arcsan found that 100% of the top 100 applications on Android had hack variants in the wild, and just over 50% on iOS. So this is becoming a real problem, and this isn't just the gaming application. This is also corporate applications that we have to deal with to make sure that people aren't exfiltrating our data by phishing people into rogue apps.
Can you talk a little bit about how these attacks work, so can you break it down
for
us?
Sure. So the attack vector here is pretty straightforward. So first of all, keep in mind that many of these applications are built with things like Java and JavaScript, which are pretty easy to reverse engineer. So what an attacker will do is effectively take the application, start the process of reverse engineering it, and one of the things they'll do in the process is find the areas in the application where the app calls out for security provisions, things like asking for a password or maybe checking for jailbreak or root detection. And if they can find those lines of code, they can just render those lines of code non-operable, recompile the code, re-sign it, and then post it on a rogue app store and then phish people into the application. Now, of course, along the way, they're highly likely to also inject their own malware into the application as well. So, if you think about this from an enterprise construct, let's say you're, for example, a bank, and you've got a banking application that people are checking their balances and processing money. Or, maybe you're a retailer and people are processing online transactions through your retail application. Well, you want to make sure all those transactions are integral, that those applications that people are using haven't been hijacked, and that that's actually your customer on the other end.
Obviously some sophisticated stuff out there, but what's most interesting to you about it? What makes it unique?
Well, I think what makes it unique to me is if we think about someone attacking, let's say, a website, right? You go out, you start to find vulnerabilities in a website, you start to attack it. Well, I can see that activity coming at my website, and I can build the various provisions to prevent people from doing that. But with a mobile application, these mobile apps they're out there on their own. I don't know when someone's trying to hijack the application. They could be working on their own lab for days, months, weeks, even years trying to hijack into that application. And I'm not going to see it until they're successful. And even then, I've got to be able to recognize, to know that that's actually you, not someone trying to pretend to be you, hijacking that application.
So what are some steps that organizations can take, both organizations that have employees with sensitive data on their phones and also those organizations that create their own native apps that perhaps they do transactions as well, like with their customers? What can they be doing?
So a couple things they can do. First of all, let's scan the applications as we're building them. Make sure they're sterile. So you got to be able to scan the source code, both on iOS and Android or wherever you're building the application. Second thing you've really got to do is, as that application now kind of goes into production, you've got to instrument that application with capabilities to look for malware and to look for mobile risk indicators, right? Like, has there been a password set? Is the device jailbroken or rooted? Jailbreak and root hiders, believe it or not, these things actually exist. But I can also look at things like the orientation of the device, or has the device suddenly moved from, let's say, Chicago to the Ukraine over the course of 2 hours? Well, that's not possible. That's something we call IP velocity. So these toolkits are readily available. But in addition to that, developers want to obfuscate their code. So once they're done building it, they want to obfuscate that code and make it extraordinarily difficult for an attacker to go in and try to reverse engineer it.
Obviously some interesting stuff in terms of the threat landscape for mobile. Caleb Barlow, Director of Mobile Security at IBM, thank you so much for being with us today.
Thank you.